Hi guys, in this lesson we're going to be taking a look at scale drawings, which is the next part in rates and ratios. This is kind of like a real world application of ratios now that you know how to divide into ratios and use ratios and all that kind of stuff. One thing I will point out at the, at the very start of this video is you do need a ruler for this kind of stuff, and that means you do need a ruler in your HSC as well. I'll show you why later on in some of the examples that we do. But in some questions in your HSC, you could be given a diagram and you would literally need to rule and figure out what the ratio is between like the length on that page and then the real length which will be told in the question. So yeah, without trying to ramble on too long, you need a ruler for this. If you don't have one today, get one before the HSC, basically. You need a ruler. I guess for today, I think you can get rulers on your phones, like a little ruler app, so I guess you can maybe use that for today, but whatever. Anyway, going into today's thing, so this, like I said, this is just an application of ratios. So ratios are used in scale drawings, such as maps or diagrams. This scale ratio and scale ratio is the main thing we were talking about today, and that scale ratio is always written in drawing length to actual length, meaning that whatever numbers on the left side is that model that you have. So whether that's a map, that's a diagram, it's a globe, it's a whatever you have, is that's kind of a representation, and on the right is the actual thing. Now, most of the things that we're going to be talking about are maps and all that kind of stuff, where 1 centimeter might represent 1 kilometer in real life, and we'll talk about that in a second. But you could also have models where the drawing length is greater than the actual length. Say you got like a picture of a cell, alright, so in biology or something, where the actual length is actually smaller, but you keep that same order. Scale ratios are always drawing length, so that model length on the left and the actual length on the right. Anyway, one thing I'll suggest as you're doing these questions, as they've written there at the bottom, is finding the scale factor is quite useful in these problems. What I mean by finding the scale factor is thinking about what number, if you were to multiply, takes you from that left side, that drawing length, to that right side, because you can kind of use that number rather than having to kind of always work with ratios. If you can kind of narrow it down to one number, which we're going to call the scale factor, then everything else can come basically from that. So I'll give you a second to pause this video so you can write that all down. Like I said, need you writing this down because we proved it's more valuable than just watching or reading. So pause now, write it down. Okay, going to the examples. So again, I've just picked out some examples from the exercise, so we'll get right into it. So looking at question A, it's the level 1 question. A scale drawing has a scale of 1 to 75. Note that that means it's just 1 to 75. It doesn't say it's 1 centimeter to 75 meters or anything like that. It's just straight 1 to straight 75. That means that the unit doesn't really matter. And that's generally how we want our scale ratios to be in. So if I were to measure 1 meter, that would mean 75 meters. If I measured 1 centimeter, it would mean 75 centimeters in real life, so on. The other thing that I'm going to talk about, like I mentioned in the previous thing, is talking about the scale factor. And the way that you find your scale factor is simply getting that right side, 75, and dividing it by the left side. Now this time it's obviously going to be quite easy. So our scale factor is simply going to be 75 divided by 1, which is obviously just 75. So we're just going to keep that number just in our mind for as we're doing this question. We're going to call that the scale factor, and it's just a lot easier just to think of it as one number. So, going from this, find actual length. The drawing length is 15 millimeters. So, again, we are getting our actual length. So, we know that, remember going back previously for a second, we've got that left side, the drawing length goes on the left, and the actual length goes on the right. So that means we have 15 millimeters on the left, and on the right side, well, that's what we're trying to find. When we're going from that left side, trying to get it to the right side, we're going to multiply by that scale factor because we're making it bigger. Okay, our scale factor is generally taking our it's that number that we multiply to get from the left side to the right side. So if we just do 75 times 15, so that's right, 75 times 15, we'll get 1125 millimeters. Now that's fine, you could just leave it as that. That technically is your answer, like the actual length is 1125 millimeters, but that's kind of tricky for us to kind of think about what that means. So of course we can do 1125 if we want to change this into centimeters. We'll divide that by 10, so that will give me 112.5 centimeters. Or we can make it even a little bit easier, 1.125 meters. Again, of course, just dividing by 100. Right. So what we're saying is, if we had this map and we measured 15 millimeters on our map, so 1.5 centimeters. That means in real life it's 1.125 meters. So obviously it's not a massive map that we've got here. Here for question B is we want to find the drawing length if the actual length is 3 meters. So this time we're going to go in reverse, because this time we know what the actual length is. We know what that right side is. So we're told that the actual length is 3 meters, I believe. Yep. So we have 3 meters. And we're going to divide that by our scale factor, because now we're going from the right to the left. So that's basically why I was talking about finding the scale factor makes it really easy, because then you just need to think which way you're going. Are you going from left to right, multiply, right to left, you divide. Now I could just do 3 divided by 75, but obviously if you do 3 divided by 75, we're going to get some decimal number. So what I might do is I might just change this into 300 centimeters. That will make it a little bit easier. Because now if I do 300 centimeters divided by 75, it gives me 4. And there's my answer. Now if I just did 3 divided by 75, like 3 divided by 75 gives me 0.04. Now that wouldn't be too hard to do. We just realized that we got 0.04 meters, and then you could just times it by 100 at the end, and that would give you 4 centimeters. That still does work, but I just kind of preempted that and changed it at the start. Up to you which way you do it, because as you see, you still get the same answer. Okay. The way that we can check to see if we're right is, of course, like I said, if I'm going from left to right, right to left, sorry, I divide, that means I should be able to go the other way. If I do 4 times 75, I should get back to 300, because they're in the same unit. Okay, making sure that we're saying that these units are the same. Okay, we're not saying that 4 meters represents 300 centimeters in this map. We're saying that 4 centimeters is 300. So that's that. So fairly simple. Going into this next question now, and this is what I was talking about earlier. This is where you need a ruler, not only in this textbook question, but also in the HSC question that we're going to do in a second. And this is actually something that pops up back in the general days, at least. It will pop up once a year, really just to check to see if students bother bringing a ruler. And if you don't have a ruler, you can't do this question. So you don't want to be that guy that doesn't bring a ruler to their exam and loses marks simply because they couldn't rule something. Okay? So looking at this, and if you have the question in the textbook in front of you, you can get out a ruler and measure it. But I've already done the measurement already. We will measure this here to be 4.3 centimeters. And we will measure this later on, this wingspan, to be, I think it was 2.8 centimeters. And we've got some other things that we'll measure later on, but let's just start off with that. So scale drawing of the space shuttle is shown opposite. There you go. The actual length of the space shuttle is 43 meters. So length in this case would be that horizontal distance from its base to its nose. So that's at 4.3 centimeters I've done there. And that's 43 meters in real life. So what is the scale factor? Now this is where my terminology gets a bit weird, because I was just telling you that the scale factor is that one single number. Whereas here the scale factor is kind of asking you for that ratio. Doesn't really matter either way, but we'll just go through it. So what we're told here, the length in this diagram is 4.3 centimeters, and the length in real life is 43 meters. Now we could leave it as that, but the thing with ratios, as we would have talked about in previous things, is it's always best to simplify it. It's not good for us to leave that ratio as 4.3 centimeters equals 43 meters. If we can simplify it, we should. And we definitely can. You can see there's similarity between those two numbers straight away. They both have 403. What we can't do, though, is just do 4.3 over 43, and there you go. Reason being, as you can probably see, is they're different units. Okay, because they're different units, that means we can't just convert them straight away. We can't simplify it straight away. We need to first change it so they're in the same units. So what I'm going to choose to do here is I'm going to make that right side into centimeters. So now we have 4.3 centimeters is, and so what we'll just times it by 100, so 4,300 centimeters. Now that they're in the same unit, we can basically just get rid of the units at this point, because now, conclusively, this ratio is 4.3 to 4,300. But that's still not where we want to finish up yet, because again, our ratio isn't simplified just yet. Last thing we can do is just simplify. Remember, ratios just work like fractions. So we can just put into our calculator, do it to the side, so like 4.3 over 4,300. We just put that into our calculator, 0.3 over 4,300, press SD to change it, so that gives you 1 over 1,000. So that means our ratio is 1 to 1,000. And that's just a bit easier, and that's our scale ratio. And then talking about what I was saying earlier, that means our scale factor, that number that we can use to solve all the following questions, is going to be 1,000, because you do 1,000 divided by 1. And basically what we're saying here, that left side represents 1, so for every 1 unit on your diagram, it means 1,000 units in real life. So if we measured 1 centimeter on our diagram, that means 1,000 centimeters in real life. If we measured 1 meter on our diagram, that means 1,000 meters in real life. So on. That's why we don't generally include units in our ratios, just so it is flexible and adaptable to where we have. Looking at question B. Calculate the length of the wingspan. The wingspan is just from that to there, so that's why I measured that earlier. So 2.8 meters, 2.8 centimeters, sorry, on this diagram. And again, just going back to that concept now, we have 2.8 centimeters, and that's that left side, okay, because that's the drawing length. So now that we know our scale factor is 1,000, we're just going to get that, and remember, when you go from the left to right, you multiply. So we're just going to do 2.8 times 1,000, which is 2,800 centimeters. But again, that's not going to, like, 2,800 centimeters, let's not leave it as that. That's not very pretty. Let's instead change that to be 28 meters, because that makes a bit more sense. Obviously, again, I just divided by 100. Because the question is asking what's the wingspan, might as well put it in meters. I don't think you ask for it in meters now. Calculate the width W of that, so I'll just get out my ruler. I haven't done this next one. So when I get my ruler and I just measure this on the page, I have a textbook in front of me as well. What's that? That's about 1 centimeter. So that means if we want to calculate the width of the shuttle, it's just 1 centimeter. Again, we'll just get that 1 centimeter times it by 1,000. And what is the length of the nose of the shuttle? I guess that's that white bit at the front. Maybe it's just whatever it is. I'm measuring it at 1.2 centimeters. So again, we'll just get that 1.2 centimeters times 1,000. What we're trying to say here is that scale factor of 1,000 stays the same the whole time. I'm not going to bother writing down the answers for C and D. It's essentially the same thing again. Just measure it on your page, get your ratio, and take it from there. Now, of course, your measurements are going to not always be perfect. just know how to use a ruler, and then it'll get you close enough to it. Like if you find the ratio to be 1 to 9,900, sorry, 9,900. Like if you found it to be 1 to 990 instead of 1 to 1,000, generally we're going to allow for a bit of variation, but as long as it's not too far off. But again, you need a ruler to do this. If you don't have a ruler, you just can't, like, unless you fluke it, but whatever. Always have a ruler from this point on when you go into a maths exam. Anyway, going into this last one, this is just from Project Maths. Once again, it's one of the sample questions that NASA gave out to help the new standard people with no past papers. So just look at this. So part of the map is shown, is this map. And we're told at the bottom that we've already been told that the scale is 1 to 50,000. Again, it doesn't give you any units. That means 1 centimeter in real life means 50,000 centimeters in real life. If we measured 1 meter, it would be 50,000 meters and so on. What is the actual distance between Mount Blackberry and Fairy Hill in kilometers? Now, on the actual page, if you got out your ruler, it says Project Math tells us that it would have been 2 centimeters. And like if you had the actual exam in front of you, that would make it so it would be pretty obviously 2 centimeters. That's one thing I should mention. There shouldn't be too much variability because they make the question so obvious for you with these measurement points. So you just got to measure it. So we're told that our scale is 1 to 50,000. That means our scale factor, I'm just going to call it SF, is going to be 50,000 divided by 1. So it's just going to be 50,000. And that's going to be the number that we're going to use to multiply and divide again. So we're trying to find the actual distance. Starting for question A, if we knew our drawn distance was 2 centimeters, right, as we're told there in the question. So remember, going from left to right, we're going to multiply. So 2 times 50,000 is 100,000, but we're not going to leave it as 100,000 centimeters, of course. Best thing we should do, in fact, the question does say in kilometers. So if you just left it as 100,000 centimeters, that would be wrong because it says in kilometers. And the other thing is, if you just change the centimeters to be kilometers, you're essentially saying that 100,000 centimeters is 100,000 kilometers, which is definitely wrong. Alright, so make sure you do the conversions properly. So let's change this into meters first. So I've got 100,000. I'm going to divide it by 100 to change this into meters. So I have 1,000 meters, and of course that's just 1 kilometer. So 2 centimeters on this map represents 1 kilometer. So that means the actual distance between Mount Blackberry and Fairy Hill is 1 kilometer. Making sure we're answering the way that I want us to. Now on the next questions, 2 bridges not shown on this map are 7.5 kilometers apart. How far apart on the map would they be in centimeters? So this is just the opposite of what we just did. This time we know what the actual distance is. So we know what the actual distance was, which was 7.5 kilometers, it said. Yep. So we have 7.5 kilometers. And this time we want to find that drawn distance because the question is asking how far apart on the map would they be. So essentially, what's that drawn distance on our scale, on our map? And again, we need it in centimeters. So that should be the first thing you should do. Straight away, if you just did your 7.5 and divided it by 50,000, again, you're going to get some really, really small number, and it's going to be ugly to work with. I'd suggest you change that 7.5 kilometers into centimeters before you do the division. So this can equal, so we've got our 7.5, let's change that into meters first. So that's 7,500 meters. And then, of course, let's just change that to centimeters, so we'll times it by 100. So we have 750,000 centimeters. Alright, so we have about 750,000 centimeters. That's how far apart those 2 bridges are in real life. And remember, going from the right to the left, we divide now. So 750,000, we're going to divide it by 50,000, which was our scale factor. So therefore, we have 15 centimeters. And there's your answer. So the distance on the map is 15 centimeters. Again, the way that you can check to see if you're right is do the opposite. If you do 15 times 50,000, you should get 750,000, then you can bring it back to 7.5. But you just gotta, like in this question, it's not telling you exactly what is the drawn distance. The question is saying how far apart on the map will the two bridges be, which is essentially saying the same thing, just in a different way. So again, this is one of those questions where you just got to read the question carefully, think about what it's saying. Anyway, as you can see, there's nothing really too much to it. The main thing to this lesson is finding that scale factor, which is taken from that scale, and then it's just realizing, what do I have? What am I trying to find? If you're going from left to right, you multiply. If you're going from right to left, you divide, making sure that you remain that left side of the ratio is the drawn number, and the right side is the actual number. Anyway, start working on those questions, and hopefully you find this pretty easy. So yeah.